Actually, this is such a great time for researchers doing what I'm doing in transplantation, because finally we are having the connection between the clinical trials, trying to evaluate the different effects in immunosuppression and balancing the side effect of the new drugs. So we have the opportunity to run the mechanistic studies using all the new omics stuff. So I have been able to present my own results, and also to see what my collaborators and other teams are doing. And I believe that we are going to see a big difference in very soon about biomarker and the impact that they can have in the benefit of the patients. I believe that the main focus is to try to find non-invasive biomarkers that can allow by early detection of tissue graft injury, and also that can be applicable to clinical labs. So we need to move from high throughput technology to a minimal set of biomarkers that any clinical lab can apply, and moreover, that is really little invasive, so the patient can be monitored periodically before the damage is already present in the graft. Yes, actually, specifically what we are doing, we are, after we perform a set of protocol biopsies in more than 200 patients, now we are testing how those biomarkers in the biopsies relate with both compartments, urine and plasma, and trying to find those biomarkers for being evaluated more often without the need of an invasion. And we are using cell-free microRNA that are very easily to test using clinical platforms. The human transplant model is a complex model. We are specifically, we as a society, we have been doing great in short-term outcomes. Outcomes at 1 year post transplantation, we achieve our goals. So right now we need to try to keep that graft, that is a pressure gift, working as long as possible. So honestly, we believe that we need to apply more than one omic approach, meaning that more than one layer of biological information is going to be needed for having the final answers. So specifically what we are doing is we are combining epigenetics, using DNA methylation, microRNAs, and the effect of those two major components of the epigenetic regulation in the gene expression. My review, it was the first step of a set of papers that or manuscript that we are that are coming from my team, and I wanted to open the door of the utility that epigenetic modification can have in clinical transplantation. Just to clarify, epigenetic modifications are those changes that happen at the level of the DNA without affecting the base. The base, they are another kind of modifications like DNA methylation. But they play a critical role in physiological functions and also in pathological conditions. Cancer is a field that is always behind, and they are already running specific applications about this. So I'm trying to take what the oncologists are doing in research and apply it to transplantation. And I honestly believe that we are going to have answers and maybe new therapeutic interventions. Working in transplantation means that you need to be part of a multidisciplinary team. I believe that there is no way that you can succeed without establishing a network. Usually, working in kidney transplantation means to have a good relationship with the transplant surgeon, with the nephrologist, and moreover, because we are running such a complicated reactions that are producing so much data, we also need to work with bioinformatic people. So that is what I have been doing, and I spent a lot of time creating the network. So, and I'm pretty sure that it's the same thing that my other colleagues are doing. So right now, transplantation and biomarker discovery in all the different teams include a multidisciplinary team. I depend on them in the samples, establishing the study endpoints, and I provide my knowledge about the mechanistic studies. It has been very clear that we all know that we are using an imperfect gold standard. That is the kidney biopsy. We are all now conscious about that we need to add new and different surrogate markers, as well as redefining the study endpoints. And I have been participating in ATC during the last 16 or 20 years, and this year there is a consensus among the different groups about how to do that, how to move on with that. And I believe that finally, if we have an agreement, we are going to be able to compare results among different clinical trials. And so it has been a really positive experience about that. I believe that what excites me the most is that we are living an amazing time in science. And finally, I believe that the basic scientists and the translational scientists, plus the physicians in this field, we start talking the same language. And now we are going to see how we can succeed and benefit our patients. That is the end of what the main goal.